Okay, everybody, here's today's lesson. It was on logarithms, which are kind of cool. So logarithms really are exponents, okay? So today we're going to talk about evaluating logarithms with different bases. Logarithms are exponents, okay? So we started with an exponential problem. We know that 1,000 is equal to 10 to the third, okay? In fact, what I could do then is rewrite it in log form, and rewrite as log of the base 10 of 1,000 equals 3. Now log base 10, that's in our calculator, okay? So we actually wanted to test this out. I go to my calculator and I go to log. The log button's right there. Go to my log button, log, and I hit 1,000. I get 3. So logarithms find exponents. So logarithms are basically exponents, okay? Now, because we live in a base 10 world, then anytime you see just plain old log, it means log base 10, okay? So for example, if I wanted to find 10 to what power equals, say, I don't know, 321, 321, I would just take the log of 321, and that's what the answer is. So 10 to that power is 321. So I'm finding the exponent. That's what logarithms do, okay? So here's another way to look at it, okay? So logarithms, you take an answer. So you take base to an exponent is equal to some answer. That's this. And I can rewrite it in log form, okay? Now there's another base, special base, and that's base e. So this is the number e, okay? And so if it's base e, then it's log of base e. But we don't call it log of base e. We call it natural log. And that's also in our calculator right there. ln is natural, you see it is with the e. So anytime you see ln, you know it's base e, okay? And that's the number e, okay? So, first example, we changed it to log form, okay? So we went 3, that's my base. My base is 3 to the x power equals 81, okay? So just change 3 to the x power equals 81, and sure enough, x is 4 because we know 3 to the 4th power is 81, okay? B, we want to change it to exponential form. So ln means log of base e. So then we're going to go e to the 2 equal e to the x equals 2. Okay, change it to log from ln to base e to the x equals 2. Okay, then we kept going on with this. Okay, change the following to logarithmic form. So we rewrote as log of base 10. Log base 10 of 1,000 is equal to x. So log, there's my base of my answer equals the exponent. B, we know that natural log means log base e. So we rewrote as log base e of x. Okay, then example 3a, we're going to go just the opposite. So here's my base. Here's my base. 2 to the x equals 32. It's rewritten in exponential form. The answer is 5 because we know 2 times 2 times 2 times 2 times 2 is 32. There's an invisible 10 here because it's common log. So if you don't see a base, it's always base 10. So it's 10 to the x equals 100, which we know, of course, x is 2. Yeah, you could use a calculator, but it's kind of fun to do it this way, okay? C, we know that ln means log base e. So we write it as log base e of e equals x. So then if I go change the exponential form, I go e to the x equals e. Well, it's got to be 1 because that's to the 1 power, okay? On the back side, when I evaluate these, I like it to equal something, so I normally just set it equal to x, makes it easier. So then I can go base, that's my base, 5 to the x power equals 1/25. Okay, now I got to do a little bit of math. 1/25 is the same as 1 over 5 squared, right? I brought up the negative 2, so x has to be negative 2. So log base 5 of 125 is negative 2, okay? E, same thing, I set it equal to x, so I can rewrite as 5 to the x equals the 5th root of x. Now, the 5th root of x, same thing as a 1/5 power, so then x is 1/5, or log base 5 of the 5th root of x is 1/5, okay? Now, I need a base here, so base 10, right? No, if it's an invisible base, always 10. So 10 to the x equals 0.0001. Well, that's the same as 1,000s, okay? Which is 1 over 10 to the third x is negative 3. Now you can check this on your calc because you can do, if it's a basic log, you can do it. Like a log of 0.001, and what do you know? Negative 3. Sure. So if it's base 10, you can do your calculator, okay? G log of base 3, so I went 3 to the x equals 1. Well, it's got to be 0. Anything to the 0 power, anything to 0 power is 1. So any log of 1, in fact, check it out, log of 1, just regular log, a log of 1 equals 0, and even natural log of 1 is 0. So any log of 1 is always equal to 0. Okay, then this one, I just changed it to 4 to the x equals this, which is 4 to the third, so x is actually has to equal 3, so this equals 3, okay? Now, log of 0, it doesn't work. Log of 0 doesn't work, and there's a reason why it doesn't work. The log of 0 should be undefined. It is undefined, wrong domain, because you can never have anything to a power that's going to equal 0. You can never, it can be a fraction, but it can't be 0. Now what we did is, we did the same thing here. It can't be negative either. So we actually looked at the graph. We knew that we took a graph at y equals 2 to the x, we graphed it, we looked at all of the x values. We just plugged in x, y values, plugged in negative 2, negative 1, 0, 1, 2, 3, and we found the values. We graphed them. But the logarithms are the inverses. So I took these values and I switched x and y, and I graphed its inverse. Here it is. And this proves why logs can't equal 0 and why logs can't be negative, because you'll see that these values are not on your graph. Your logarithms cannot equal these values at all. Okay, that's what I had for the lesson today. If you have any questions, come see me. Okay? Homework's there.